arc length. If we have an angle of measure theta and a radius of r, we want to be able to find s, which is s refers to arc length. Now, watch the nice little trick that I play here. Back in good old geometry, if you wanted to know the length of an arc, you would say arc length is equal to whatever theta is, and then you would divide by 360, and that would figure out what fraction of the circle is it, and then you would multiply that by the circumference. All right? Now, if you were to work this out, you'd end up with 2 over 360 reduces to, yeah, so you get theta over 180 times pi times r. Or theta times pi over 180 times r. I can write the theta right up front, put a pi on top if I want. That's if we're working in degrees. Suppose that we're not working in degrees. Suppose that we're working in radians. How do I convert it from degrees to radians? I multiply by 180 over pi. So if I insert that, I get 180 over pi times pi over 180 times your radius. And what do you get? What happens? The 180s cancel, pi's cancel, and you end up with this formula. S is equal to simply whatever your radius is times theta. Isn't that nice? You will use this equation from now on. We're going to get rid of this one. Don't worry about that. I was just showing work of how we got it, okay? All right. We could do the same thing for, I'm not going to show you this piece all the way through, but I will say this. If you're wondering area of a sector, it's very similar. We call area of a sector K. K is equal to, we could do this similar type of substitution from degrees to radians, and you get this formula, 1/2 r squared theta. And these are much simpler formulas to use. So we've been talking about radians and degrees. You might wonder, why do we like to work in radians? Well, I'll tell you, it's very nice for calculus. Okay, I'll tell you that first of all. Second of all, I'd like to tell you that for applications, it's a lot easier as well. So all you're going to do today is practice using these formulas. We start here. It says, find the angle in radians that satisfies the condition below. So I have a circle with a sector. The radius is 7, and it has an arc length of 3. What does it say that I'm solving for in this problem? The angle. So I'm looking for theta. Which formula has to do with arc length? The first one or the second one? First one. So S equals R times theta. What is S? R. How do I solve for theta? Divide by 7. We get 3 over 7 is equal to theta. That's it. Now, this should be a kind of a nicer, easier lesson. It's all we have to do. But I want you to understand what theta equals 3 over 7 means. Is that a degree or a radian measurement? It's a radian measurement. Whenever you use these formulas, you have to work in radians. You can't work in degrees. Otherwise, you have to use a different formula. That's why we got rid of the degree ones. We just circled those. So what does 3/7 radians mean? Well, remember, the definition is 1 radian is when you can wrap 1 radius. So is 3 1 radius? No, it's short of 1 radius. Is it even half of 1 radius? No. So does my picture really match up with 3/7? It doesn't. It should be a smaller angle. But that's what we're finding, okay? So look at this. Radius of 4, arc length of 13. So I'll try to draw this one more to scale, all right? If I have an arc length of 13, do I have more than 1 radius wrapped around? Do I have more than 2? Do I have more than 3? Do I have more than 4? No. You can see that if you have 13 total for an arc length, you have 3 and a little bit more wrapped around. So we set up our formula. S equals R theta. S is, and R is 4 theta. Divide both sides by 4. And 13 over 4 is 3.25. You can see that sure enough, we do have more than 3. You don't, but I would encourage you so you can understand what's going on. But no, I won't. Yes. Yeah, so I've got 4. That would make 8. That would make 12, and then a little bit more, right? That's what I've got going on. So you can see if you take 13 divided by 4, you get 3.25. So you've got just a little bit more. So that's what you're doing. Let's apply it a little bit more. We'll do 2 more examples. Example 5 and example 6. Example 5 says find the length of an arc and the area of a sector of a circle with a radius 24 intercepted by a central angle of 60 degrees. Right. So the question is, what does that mean? Well, here's what it means. I have a circle. What's the radius? 54. What's the angle measure? 60 degrees. And it says find the length of an arc. So that would be the blue. We call that S. And the area of a sector, the area would be that inside part, or K. Okay? Those are the 2 things I want to find. So it says with a radius of 24, and when it says intercepted, that just means that this angle intercepts. It kind of makes that arc S. Exactly. That's the point that we want to show here. This is problematic. 60 degrees we cannot use because our formulas are in radians. This is degrees. So the one thing you have to be sure you do, and I swear you will be. So you tell me, what is 60 degrees in radians? Do you remember? Pi over 3. Very good. So now I have all the information that I need. I know S is equal to R theta. So S is, what's the radius? 24. What's theta? Pi over 3. So 24 times pi over 3 would be, you can either write it as a decimal or in terms of pi. And 24 divided by 3 gives me 8. So 8 pi. Area, we'll use a different formula. K is equal to 1/2 r squared theta. K equals 1/2 times 24 squared times theta is pi over 3. Tell me, can I take 1/2 of 24 and then square it? Or do I have to take 24, square it, and then take 1/2 of it? I have to square it first because that's the order of operations. So 24 squared is 576. And then if you divide that in half, I think we get, 288. So K is equal to 288 times pi over 3. If we take 288 and divide it by 3, we get 96. So 96 pi. If you'd like to write that as a decimal instead, I will accept it with full credit. Okay? I won't make you do one or the other. You can do whichever one you want. Okay. So let's just make it just a little bit more complicated. Not much. Just a little. Oh, no. Okay, find the length of an arc and the area of a sector of a circle with diameter 24, intercepted by a central angle of 105. So I'm going to draw again a circle. And this time the angle is 105, so that's a little bit bigger. And it says it has a diameter of 24. Very good. So 12 would be the radius. And I don't know 105 in terms of radians. So what would we do? What's our conversion? Multiply by pi over 180. 15 goes into 180 and into 105. You could reduce that on your calculator as well if you want. And you get 7 pi over 12. I better pull my calculator out so we can see exactly what I'm doing here. Background? It's just a hodgepodge of stuff we put together. It's not necessarily one content or one subject. Here we go, calculator. All right. Great. So if you take, like I said, 105 and divide it by 180, and you hit math, convert to fractions, you should see you get that 7 pi over 12. But you could do this as well. Suppose you don't want to leave it in terms of pi. You could take 105 times pi, divide it by 180, and instead of using 7 pi over 12, you could use 1.83. I don't care. You do what you want. Which one do you want? Which one would you like to see me work it out as? I don't know where you're going. All right, we'll do the 7 pi over 12. Okay. All right, so I have 7 pi over 12. So now I have two formulas. S is equal to r theta, and K is equal to 1/2 r squared theta. So S is equal to, R is 12 times 7 pi over 12. Hey, what happens? The 12s cancel, leaving us with 7 pi. Again, if you wrote that in decimal form, that would be fine too. So I go to the next one. I have K equals 1/2 r squared theta. Whoop. What is r? So I'll take 12 and square it, and then theta is 7 pi over 12. 12 squared, 144. Half of 144, 72. 72 divided by 12 is 6. Times 7 is 42 pi. So I'll put in here 0.5 times 12 squared times 7 divided by 12. You do all that, you get 42. And again, we just attach the pi. So that'll be in terms of pi. If you don't want it in terms of pi, you can raise the decimal. That's all we have for today. Okay? So I'll give you a short assignment on that. It is a book assignment today. Okay, for your assignment, you can see that you have 79 through 82. That's where you're finding theta. That's like the first thing that we did. And then 87 through 94, half of them are finding, half of them are finding arc length, and the other half are finding area. Okay, so just like the stuff we did today, there's 12 problems there. What should be? Enjoy your weekend.